Hello, my name is Mohammed, from Arab Modern Industries. Welcome to our technical channel.
Let us speak about the stepping motors. What is the stepping motor and how it works? The stepping motor, also known as the stepper motor or the step motor. There are three main types of stepper motors. Permanent magnet stepper motor. These motors have rotors that are constructed with permanent magnets, which interact with the electromagnets of the stator to create rotation and torque. Variable reluctance stepper motor. These motors have wound stator, and the rotor doesn't have magnets. It is an iron disc with small protrusions called teeth, where the controller energizes every pair of opposite windings independently.
Because the rotor is made of iron, its teeth are attracted to the energized windings. These teeth in the rotor align with these windings to provide a path for the magnetic flux between the opposite poles. Hybrid synchronous stepper motor. These stepper motors use the best features of both PM and VR motors. The rotor in HS motor has a permanent magnet core, while the circumference is built from plain iron and has teeth, therefore, it has both high angular resolution and high torque. And now, let us recall some facts and theories. Together, we recall Fleming's right-hand rule. This rule said, if coil is grasped with your right hand, where your fingers point to the direction of the current so, your thumb points towards the North Pole. Recall another thing. The rule to remember is that the similar poles repel each other, and different poles attract each other. Let's talk more about the hybrid synchronous stepper motor. In the beginning, we talk about the motor rotor, and explain what it consists of. Actually, the rotor is a magnetized rotor with toothed steel caps. So, one end of the rotor becomes a North Pole N, and the other end becomes a South Pole S. The accuracy of these motors depends on the good teeth arrangement of the rotor and the stator. Let us understand it first. For example, assume this rotor has 50 teeth arrangement. The stator actually has 2 fewer teeth than the rotor. That means 48 stator teeth in this example. These 48 teeth is arranged in 4 groups called poles, represented as red, green, yellow, and blue. The red set is completely aligned with rotor teeth. The yellow set is completely unaligned with rotor teeth. The other 2 sets, green and blue, are half aligned with rotor teeth. The motor step angle is depending on the number of rotor teeth N and the number of stator poles P. The motor step angle formula is as shown. In this example, the step angle is 1.8 degree. Now, come with me to make things easier together. We will show a simple simulation. Suppose a rotor with total 48 teeth. 24 teeth as a North Pole N, and other shifted 24 teeth as a South Pole S. The North Pole is represented as a red color. The South Pole is represented as a blue color. This simple simulation presents a simple hybrid synchronous stepper motor. with 48-teeth rotor and a simple 2-poles teeth stator, as shown as following. The stator consists of 2 poles represented as 4 coils, A and A dash, B and B dash. Back to the right-hand rule. When the first pole is activated, so that A is positive signal, and A dash is a negative signal, this stator pole will be a south pole, represented as blue color. When the second pole is activated, so that B is a positive signal, and B dash is a negative signal, this stator pole will be a south pole, represented as blue color. When the first pole is activated again, but A is a negative signal, and A dash is a positive signal, this stator pole will be a north pole, represented as red color. Also, when the second pole is activated again, but B is a negative signal, and B dash is a positive signal, this stator pole will be a north pole, represented as red color. Now, let us see a complete cycle for the stator activation. Here, we read back the 48-teeth rotor to the motor construction, waiting for the activation pulses, as same as we learned previously. By activating the first pulse, the A and A dash pole will be a south pole, so it attracts the rotor teeth of the north pole. By activating the second pulse, the B and B dash pole will be a south pole, so it attracts the rotor teeth of the north pole. By activating the third pulse, the A and A dash pole will be a north pole, so it attracts the rotor teeth of the south pole. By activating the fourth pulse, the B and B dash pole will be a north pole, so it attracts the rotor teeth of the south pole. Repeating the complete cycle of pulses, the rotor of the motor will be run. Repeating the pulses. By increasing the speed of pulses, the speed of rotor will be increased. For the full control and operation, the stepping motor must be connected to a drive. The drive converts the pulses signal from PLC, or any other controller, into the stepping motor. A command with one pulse causes the motor output shaft to turn by one step. The amount that stepper motor rotates is proportional to the number of pulse signals given to the drive. The speed of the stepper motor is proportional to the speed of pulse signals. Pulse frequency given to the driver. The stepper motors can be held at a stop position without using a mechanical brakes. Once the power is cut off, the self-holding torque of the motor is lost. In the upcoming videos, we will learn together about servo motors and their applications. And we will make a comparison with stepper motors, showing the advantages and disadvantages of the two types. Thank you for listening, and best wishes. See you soon.